Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about a MeerKAT peeking at our universe. And if I have time, which I probably don't, Jupiter is hogging all the moons, and maybe someday I'll get to that story about another cute baby planet. And of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. So call 888-581-0708 to join the conversation. And today's Blue Shift, I'll be talking about why that MeerKAT matters for Africa. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent of the stars. Got an exciting show for you today on Space Radio, where we talk about all things in the universe. This show lives on listener questions. We record every Thursday here in Studio A of WCBE Radio Columbus, except for today, where I'm not in Studio A. More about that later. So call 888-581-0708. You can also follow the live streams on YouTube and Twitch. You can be one of the amazing space cadets watching live from Texas Hills, Orange County, California, Stockholm, Sweden, Cape Town, South Africa, Austin, Texas, and more from around the world. Go to spaceradioshow.com for the links. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking questions, though, I wanted to share some interesting bits of news I caught recently. And perhaps the most important thing that I saw this week is the inauguration of a brand new telescope in South Africa called MeerKAT. MeerKAT stands for something. I'm sure the T at the end is telescope. It's named after the iconic small mammals of the continent, of course. And radio astronomy is a big deal. Radio astronomy lets you see things that other wavelengths can't. Radio astronomy can peer through clouds of gas and dust. Radio astronomy lets you see the behavior of magnetic fields, which play a very important role throughout our universe. Radio astronomy is a major window into our universe, and especially to regions of intense activity. If you have charged particles flowing very fast, they create a magnetic field, they will generate radio waves, and we can see these radio waves. So if you're interested in interesting parts of the universe, then radio is an excellent way to see it or hear it, depending on your metaphor of choice. And radio waves allow us to build some really fantastic instruments where you're not just limited to a single instrument, a single dish, a single antenna. You can build arrays, multiple sets of dishes or antenna that can collect radio waves. And then later on, you integrate all of these bits and pieces of information that they all captured separately into a single coherent image. This is a process known as correlation in the biz, if you ever need to pretend you're an astronomer. And this allows us to build gigantic arrays that each individual dish may not be so big, but there are so many dishes and you can spread them so far apart. And the farthest apart your dishes are, that maximum distance, that is the equivalent resolution as if you had a single giant telescope that size. So MeerKAT, to give you an example, is 64 different dishes. The furthest pairs, the most distant ones, are 5 miles apart. 5 miles apart. Imagine if I just walked up to you and said, hey, I'm going to build in a radio dish that is 5 miles wide. You would not believe me, but then here we are, because we don't have to build the whole dish. We can just build pieces of the dish as separately in small little bits, and then later work out how to glue them together and combine all their separate images. And the MeerKAT, as their inaugural image, gave us this gorgeous, gorgeous view of the center of our Milky Way galaxy and the region around our own supermassive black hole, a region a couple thousand or about 1,000 light years across this image. And go to spaceradioshow.com. There'll be an image of this for the episode. Absolutely gorgeous image. You see these areas of bright intensity of radio emission, these strange globules off to the side, these long arcs of representing magnetic field lines that are winding around our central supermassive black hole. Absolutely stunning image. Congrats to all the technicians and engineers at the MeerKAT radio telescope, and happy observing for decades to come. And live streamers, you may have noticed I am not in studio today. So I'm doing it all myself. There's no Greg. And you may have noticed me rip my headphones out. I'm using some special software to combine the callers and audio I'm about to play and my own voice, but there's a tiny delay on it, and it drives me nuts. It's the most distracting thing in the world. So, but now I have to put my headphones in because I'm going to play a voicemail, and I'll do my best to not let it drive me insane. Sorry, Greg. I need you in my life. And like I said, I am not in studio today. I'm traveling in the wonderful and wonderfully hot city of Washington, D.C. I'm here shooting the next season of How the Universe Works with the Science Channel. It'll be out sometime, maybe spring-ish of 2019. So stay tuned for that. I will be in quite a few episodes, probably all of them, depending on how well the interviews go, if I really do know my space stuff. I'm also here for a conference. I'm keynoting a conference for the Department of Energy. Great time. And no, I don't have my Greg here with me, so I'm producing the show all on my own. And I can tell you, it is a challenging thing. Even though I'm traveling, I can still take callers. That's 888-581-0708 to join the show. And that, even if I'm not in studio, we have the technology to take calls, and we can take these calls 24/7. I'm not going to answer, 24/7. I'm only going to answer when we're recording Thursdays at 4 p.m. Eastern. But you can leave a voicemail. You can leave a voicemail, and I will play that voicemail without even listening to it ahead of time, which is always going to be a dangerous thing. And I will answer that question. Exhibit A, I'm going to do it right now. We got a call. So here we go.
Hi, Paul. This is Keith from Olympia, Washington. I'd like to hear your thoughts on the possibility of sending telescopes light years away with the idea that we would use them to image the Earth. Do you think that we would be able to send telescopes light years away and maybe see dinosaurs in detail? Anyway, I'd like to hear your thoughts. Thank you.
Great question, Keith. So much fun, because it brings up a few issues about astronomy. We're told, and we're correctly told, that the farther away something is, the older it really is. So the light we're getting from the sun now was released from the sun about 8 minutes ago. So that image of the sun, if you could look at it, please don't actually look at it. If you could look at it, it's as the sun was 8 minutes ago, not as the sun is right now. If you look at a distant star that's 10 light years away, it's not as the star is now, it's as the star was 10 years ago. Look at the center of our galaxy, this MeerKAT image from the center of our galaxy, that is 25,000 light years away. It's the center of our galaxy as it was 25,000 years ago. So the question here from Keith is, can we send a telescope really far away and look into our own past? There could be. So the dinosaurs were around, say, 6,500 million years ago. Let's go back to 100 million years ago. If there is an intelligent civilization 100 million light years away from us, and they were observing the Milky Way galaxy, they were observing our solar system, they found our planet, and they have gigantic telescopes, like unimaginably big telescopes, and they could see our little rinky-dink planet whizzing our way around the sun and look in and zoom in on the continents and amongst all the foliage, they would see dinosaurs walking around. That light that the dinosaurs emitted 100 million years ago is traveling through space right now, and some lucky alien civilization is getting to watch the dinosaur show right now. But this doesn't mean that we'll be able to see the dinosaurs, because in order to see that light, we would have to catch up with that light, overtake it, then turn it around, and then let the light hit our telescope. And we can't travel faster than the speed of light. So that expanding wavefront of light, that shell of light that was emitted 100 million years ago and now is contained within a sphere 100 million or 100 million light years in radius, I'll get that right one of these days, it is continuing to expand at the speed of light. We can't go faster than the speed of light to catch up with it to actually see it. So I'm sorry, Keith. Don't worry, this bums me out too. We're never going to get to see the dinosaurs, which is a bummer. But there's other cool things that we can see. Maybe if we had a powerful enough telescope, we could see alien dinosaurs in a distant galaxy. That would be awesome. And even if we could, Keith brings up another good point about just sending telescopes into space. We have space telescopes. We have Kepler. We have Hubble. We have Planck. We have a few others, and we're planning a few more. Could we send a telescope way beyond the solar system, maybe even into a distant solar system, to capture some good information? There's going to be a really, really tough cost-benefit analysis that you're going to have to do if you want to send telescopes into space, and if you want to send telescopes really far into space. And I'm telling you now, it's probably not going to work out for you. Great question, Keith. That was by voicemail. I'm Paul Sutter. This is Space Radio. This show is brought to you by you. Go to patreon.com/PM Sutter to learn how you can make this show happen. You are really supporting this show, no matter in the world, where in the world I am. I appreciate it. You're welcome. Keith Crash is a real toughie. That is a very long name, but happy to answer your question. It was a good question. Don't listen to the haters. Send some more questions my way if you want me to answer them on the show. Getting ready for the next segment here. I've got a couple questions I saw at the top of the show. One from Leopold Roos. Is it Leopold Roos or Ross? Now I have to scroll. Roos, it is. How do we know black holes have infinite density? Larry Beckham asking if there's anything about slow neutrinos. Jim Becker, can we heat up an atom so hot that it disintegrates? I do like that question. That's a fun question. I think I'll do that one. Let me write it down. Otherwise, when I'm in the middle of recording, I'm gonna forget it. And apparently I can't write and talk at the same time either. Stephen Ernest, do I think the universe is infinite or finite? Good questions. I think I'll do these all. I'll do them all. I'm going to do 4 questions. Stephen Ernest. I'm going to do a bunch. I'm going to try to do a bunch. Wish me luck, everybody. And I need my timer. It's so hard. Everything's crammed into my one little tiny laptop. Everything I need to know for the show. Okay, here we go. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got tons of listener questions lined up and ready to go. But remember, you can join the conversation by calling 888-581-0708 or by following the live streams. Check out spaceradioshow.com for the links. Coming from the Space Cadets over on YouTube, I have too many questions to handle, so I picked 4 of them, and I'm going to see if I can get to all 4 in this segment. It's a new challenge, starting with Stephen Ernest asking, do you think the universe is infinite or finite? Well, here's the thing about the word universe. It can mean different things. Usually when someone says universe, they mean observable universe. Our universe is only so old, 13.77 billion years, for those of you keeping track. Light can only travel so fast, and so in that time, only a certain amount of universe has been revealed to us. And the amount of that universe that's been revealed to us is about 90 billion light years across. So that is definitely finite. It is a bubble centered on us, everything we can see. The actual universe is, of course, much larger than that. How much larger is a matter of some debate and several mysteries. It could be infinite, straight up infinite, the universe never ends. It could be finite. Even if it is finite, it is incredibly large, something like 10 to the 52 times bigger than our observable patch. 10 to the 52, for those of you who don't know, is an incredibly large number. So that's big. So that's our 2 choices. The universe is either ridiculously big or it really is infinite. Either way, it doesn't matter. Either way, it doesn't matter because the only part of the universe that we will ever see, ever observe is our local observable patch, 90 billion light years across. That's it. That's all we'll ever have contact with. That's all we'll ever exchange messages with. That is it. Doesn't matter how big the bigger universe is. Great question. Next up, Jim Becker asking, can we heat up an atom so much that it completely disintegrates? Ooh, really juicy question. I really like this. So it's easy enough to rip an electron off of a nucleus. So you can take the electrons out of their shells around the nucleus of the atom. You don't need a lot of temperature for that. We do that all the time and call it a plasma. Disintegrating the nucleus, however, is a much more challenging task. This requires nuclear forces. Nuclear forces require a lot of energy. And this does happen in the universe. We see it in supernova explosions. We see it sometimes in quasars. We see it sometimes when ridiculously high-powered cosmic rays slam into nuclei. They can actually knock some of those nuclei off and totally disrupt the atomic structure and the nuclear structure inside those atoms. So yes, you can pull apart, you can certainly yank apart the protons and neutrons that make up an atomic nucleus. You only need nuclear power. So not impossible, just exceedingly difficult, which is fine. Another question here from Larry Beckham asking about neutrinos. Been talking the past couple of weeks about neutrinos and fast-moving neutrinos. And Larry's asking, can neutrinos move slowly ever? And the answer is no. The answer is no. Neutrinos have barely any mass. They have barely any mass, and they barely ever interact with normal matter, which means they are just going to go really, 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 really fast. I'm tired of using the word ridiculous and incredible in this episode, so I'm just going to say a whole bunch of reallys. Last question, then I see we have a caller. Very exciting. Leopold Roos, how do we know black holes have infinite density? We don't. We don't. General relativity tells us that black holes have infinite density in their centers, a region we call the singularity. Singularities don't exist, everybody. Singularities are telling us that the mathematics of general relativity is breaking down and must be replaced with something else. What is that something else? Well, I don't know. I don't know, and nobody knows. Hopefully somebody soon figures it out. Or eventually. I don't really care when. I just hope that somebody figures it out. Okay, Greg, I'm putting a pause on the timer because I got a caller here. And I'm going to talk to the caller. Hey there, caller. How's it going?
Great.
Can you hear me?
Hello, this is Luke calling along with my FLO Robotics team scientific sorcerers from Granville, Ohio.
Nice. Give me the super short version of your question. I'm not recording right now, and we'll put it in later. Can you hear me?
Hello?
Hey, yeah, there you are again. Luke, can you hear me?
We know that Mars is extremely cold and has a thin carbon dioxide atmosphere, but what are some other challenges for a Mars colony?
Ooh, okay. Excellent question. So what I'm going to do, I'm going to ask you to say that question again. I'm going to introduce you. Normally, my producer handles all this, but I'm traveling remotely. I don't have my producer here in the hotel room with me because that would be weird. Greg, don't get any ideas. Luke, so just hold on just a second. I'm going to keep you on the line. I'm going to introduce you and then ask you for your question. You just have to ask that question again. All right, here we go, and I hope I don't break something. And we've got a caller on the line at the last minute. We've got Luke. Luke, where on earth are you?
Granville, Ohio.
Granville, Ohio. Excellent place. Now, Luke, what are you curious about?
We know that Mars has a thin, unbreathable carbon dioxide atmosphere, but what are some of the other problems that people could face on a Mars colony?
Excellent question, Luke. Talking about colonization of Mars, the difficulties of being on Mars and living on Mars. When talking about the challenges that could be faced by living on Mars, it's almost easier to talk about what are not the challenges of living on Mars, because the challenges of Mars are so extensive that it's hard to even talk about where to start. You point out that there's no air. There's also no liquid water. There is frozen water under the surface, which is nice. We'll take it. We'll take it. The dirt of Mars is full of perchlorates, which is a kind of rocket fuel or ingredient in rocket fuel, and totally poisonous. So don't go licking any rocks or you'll probably die. The gravity on Mars is 40% that of Earth. So there are some real honest questions of, can humans live long term in a reduced gravity environment? Does Mars have enough gravity to survive? to allow us to survive? Can we have babies that will grow and actually have spines that go in the right direction in such a low gravity environment? So that's a challenge. You're farther from the sun, so there's a lot less solar output. So not just is it bone-chillingly cold, any sources of power that you might need that you would want to go to power a space colony, like, say, solar power, are going to be that much less efficient. And one of the biggest challenges to Mars is that it's totally empty. There's nothing there. There's no trees. There's no limestone. There's no waterfalls. Like, not just for, pretty pictures in national parks. This is useful stuff for buildings, for having houses and factories and food processing plants and farms. And just think of all the amazing interconnected, complicated infrastructure that makes modern civilization possible. Mars has none of it. Zero. It's got nothing. So we have to bring everything. If you want a pencil, there is no way to make a pencil on Mars. You have to bring a pencil from Earth. And just the sheer weight of colonization is very, very challenging with Mars. And it's not like the old-timey colonists when they would go to a new continent on Earth where there's already air and trees and food running around or coming out of the ground. We don't even get that when it comes to Mars. So I see humans going on Mars relatively soon in the next few decades. Colonization of Mars is an incredibly challenging problem. Not impossible, but very, very, here I go again, very, 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 very challenging. Excellent question, Luke. What a way to end the show. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. And yes, John Michael Godey, I am in a hotel room. I'm in Washington, D.C. This week, enjoying myself with a conference and shooting for the Science Channel and some other events. I was supposed to be in New York City last night. Can I just vent to everyone off the show? I was supposed to be in New York City last night for a big event that was going to be really exciting. Good old Amtrak, my train was 3.5 hours late. All I could do is get to Penn Station, hang around for a half hour, and then turn right back around. It drove me nuts. I couldn't believe it. All right, Blue Shift time. Hi, Kate. Siren Monitor Dance. I was supposed to be at their event. There they are. You're gonna please post some pictures on Instagram so you can share with other people how cool the event was, despite my absence, or maybe because of. How slow is Amtrak in comparison to the speed of light? Amtrak is so slow. I can't even think of a good joke. You would need the most precise ruler in existence to measure the slowness of Amtrak compared to the speed of light. Larry, yeah, I love the Air and Space Museum. So I come to DC about every 2 to 3 months, and I try to go to a new Smithsonian museum every time I visit. So I was in the Sackler Gallery today. All right, I got to record this Blue Shift. Greg's just sitting here listening. He'll be listening to all this, wondering when I'm going to get started with the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get just a little bit closer to you. And I came across, as I was reading about MeerKAT in South Africa and all the cool stuff going on in astronomy there. By the way, I've been to Cape Town. I've been to South Africa. I've talked and I've worked with a lot of people developing some very cool instruments down there. Very exciting time for the country when it comes to astronomy. And I'm not the only one who thinks that. I'm reading a very interesting article by Vanessa McBride. She's an astronomer with the International Astronomical Union attached to the Office of Astronomy for Development. This is a very cool idea. We're spending billions of bucks building massive radio telescopes in the isolated deserts of the world. And South Africa and Western Australia are two of the premier places to build radio astronomy. Especially in South Africa, the region known as the Karoo Desert is a fantastic site for astronomy. There's already a few instruments up there. MeerKAT is up there. It's going to be the site of an even bigger instrument known as the Square Kilometer Array. No prizes awarded for guessing how large that instrument will be. And this is a very cool time for South Africa and Africa in general, that as the world's scientific bodies look for interesting places to put instruments and telescopes and facilities, Africa has a lot of advantages. South Africa has a lot of advantages. And people kind of like astronomy. Kids kind of like astronomy. They like getting into it. And when they get into it, they want to learn about the math, the engineering, the technical aspects, the collaboration aspects of making something cool like a big observatory happen. And that's why the International Astronomical Union has this office, because they recognize the ability to draw people in and give them real world skills, using astronomy to hook people in, teach them very powerful, very useful things that they can go on to use to better their lives, better their countries, better their nations, better everyone in the world. Speaking of making the world a better place, we had a great time last week, as promised, at the John Glenn Astronomy Park in our Cosmic Cookout. Big shout out to the couple from Pittsburgh who came from Pittsburgh for that fun event. We had good food, we had good science, and we had an amazingly dark, amazingly clear night sky. Seriously, folks, if you haven't had a chance to see the Milky Way, drive in the opposite direction of your nearest major city and go enjoy that. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for eventually producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. And you can also follow along with the Space Cadets on YouTube and Twitch. Go to spaceradioshow.com for the links. You can also follow me on social media. My name is @PaulMattSutter on all the channels. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. We did it. We did it. I successfully hosted another show. There, you should hear me now. You should hear me. Whew. Sorry about that. I went silent. It's fixed now. Sorry. See, this is why I do need Greg. Because I use a piece of software called Audio Hijack that can take audio from the microphone and from Skype and pipe it in, mix it together, and then I pipe that out to OBS, and it also simultaneously record. And I was done with the recording, so I shut it off. And then you couldn't hear me. Sorry about that. I was just explaining to the Twitchers that you probably, sorry I couldn't address any of your questions, Twitchers. I ran out of window space. Usually I have plenty of window space, and I have my notes over here and timers over here, but I had to compress all that onto a single monitor. It's just my laptop, so it's not like I have extra monitors hanging off to the side. So sorry, Twitchers. I didn't give you a lot of love today. But know that in my heart, I honestly don't really care about you, but I can pretend to love you. Yeah, Larry, good to mess up after the show. Could you guys hear the caller and the voicemail I played just fine? How were the volume levels for you guys for that? I'd like to know. Help me diagnose my engineering and production capabilities. And of course, I need a name for the show. Give me some title suggestions. Thanks, Nancy. Good to know, so I don't have to adjust any settings next time. William, if you called, the show's over. Try again next week. That was cool who called from Granville. It sounded like they were from a high school. And they weren't just pranking me. That would have been a disaster. Space in a hotel. I like it. But the radio listeners, well, I guess I didn't say in the recorded bits if I was in a hotel. Hey, Chaos Lab. Yep, I'm wrapping up right now. Hotel space, lots of riffing on the theme of hotel. I should travel with a pop filter. You're right. I'm right up in that, aren't I? But then it's more space in my bag. It's already a pain in the neck to put this guy in and the cable and Hobart Hotel. So yeah, pop filter would be great. Or at least maybe I should get like a little foamy thing that goes over this. I'll compromise. I'll do the foamy thing. Thank you, everyone. I think I'm going to close the show. And I will... Yeah, maybe I should just title something about how much Amtrak disappoints me. Thank you, everyone. See you.